this is Chemistry 5.4, chemical reactions and energy, okay? This is a good question you can expect to see in most papers that you'll sit in the summer series. I'll be surprised if one doesn't come up. The reaction between hydrogen and chlorine to give hydrogen chloride is represented by the following equations. And then it tells you the amount of energy needed to break the bonds, okay? The amount of energy released in making bonds is equal and opposite to what that is needed to break a bond. Using the bond energy values in the table, calculate the relative energy needed to break the bonds in the reactants, okay? So straight away you're looking for the ones that are on the left of the arrow, the ones that what you are adding together to make something, okay? Then I've worked out their values and I've added it together, okay? Remember to use a calculator, don't do it in your head. Moving on then, the relative energy given out by the products. So you've got two of the same bond, the hydrogen-chlorine bond. So you times it by 2. Again, use a calculator, even if it's easy maths, just be sure. Then finally, using answers to part A, state whether the reaction between hydrogen and chlorine is exothermic or endothermic. Give a reason for your answer. So we know that you've got to do reactants, take away products, or energy in, take away energy out. So that's the values that I already worked out. Taking them away, you end up with minus 184, which is exothermic because the overall energy change is negative. Moving on to question 2, which is looking at different energy profile diagrams, and loads of people will miss out this question because there's no line. Correctly label the energy profiles. So the first one is exothermic because energy is being released, and the second one is endothermic because energy is being absorbed. State what is meant by the term activation energy, the minimum amount of energy required for a reaction to occur. So the minimum amount of energy required for a reaction to occur. Make sure if you're ever asked to label one of these energy series graphs, you are labeling that activation energy point. Explain how the energy profiles are produced in terms of energies and bonds. This question is worth 4 marks. It doesn't say which energy profile, so you need to be assuming that you need to talk about both energy profiles. So the first one I talked about was exothermic. More energy is required to break the reactant bonds than is required to form the products. Energy is being released. Then endothermic, more energy is required to form the bonds in the products than is needed to break the reactant bond. Energy has to be absorbed from the system. Moving on then to question 3, which is quite similar to a question that was asked in the acids and bases. Again, you've got a polystyrene cup, you've got a thermometer to measure the temperature change that is occurring. On the grid opposite, plot the volume of acid against the temperature and draw a suitable line, okay? So I have plotted all the points on here, and I might not be able to do it very well. So I plotted all the points. Make sure that you get them exactly. You're working out how many of them what each little square means. So in this case, it was 0.1 each of them little squares, okay? Then you plot them, that's going to get you 2 marks. The final mark is going to be for joining them up, and it says using a suitable line. Now this one isn't going to be a straight line, it's going to be, and I didn't do that very well, a curve, okay? You need to make sure you get as many points as possible in. It is a curved line. Moving on then to the questions at the bottom. Maximum temperature rise. So what is the starting temperature or the smallest temperature? In this case, it's 21. What is the highest temperature that it reached, which was 26.5, because each little square equals 0.1. So take them away from each other and you end up with 5.5. The volume of acid needed to neutralize all the alkali, which is the top volume, okay? The top volume. Okay, and in this one it is, I've written that down wrong, in this one it is 50, okay, because that's the top one, not that, I've recorded the temperature, so you can straight away see even I make mistakes. It is 50 because that's the top value where the peak of your graph is. Moving on to the the question, well, part C of that question. It is important to reduce heat loss during this experiment. State how the amount of heat loss is reduced during the experiment and suggest what else could be done to reduce heat loss if the experiment was repeated. So the first thing is stored in a polystyrene cup to insulate it to limit the amount of heat loss. What you could do to limit the amount of heat loss even more, which would get you a second mark to this question, would be to add a lid to the cup so no heat can escape because hot air rises. Choose from the box below a term that would use to describe this reaction. It is exothermic because heat is being released, heat is exiting, there is a temperature increase. Okay, question number 4, which is a little bit of a different 6-mark question. It'd be quite nice if it came up with a 6-mark question. So straight away, I'm highlighting them keywords. I'm working out what I've got to do. Explain how bond energy values show that the formation of hydrogen chloride is exothermic. So you've got to work your way through to decide and describe how it is exothermic. So the first thing I did was label the products and the reactants. I then, for 1 mark, worked out what the reactants would be. Okay, you've got all the bond energies, worked out what the reactants would be. Second mark then for working out what the products would be. Remember, you've got 2 of that hydrogen chlorine bond, so you've got to add them together twice. Okay, you could be, which might be an easier way, every time you do it, you're crossing out the bonds, so you know that you've worked them out. You're crossing out the bonds. Moving down then, working out the bond energy. So you get 1 mark then for remembering that it's reactants take away products, or energy in, take away energy out. And then a second mark then for working that out. Remember, at all points you should be using a calculator just to be sure, even if you've got really good math skills. Final kind of mark then, exothermic because the temperature increased or the overall energy change was negative. You could have written either of them things to get the mark. And then again, 1 mark for SPAG and organisation. So that's a really nice 6-mark question there. 4 marks before you even had to write anything. It's just doing some maths equations. Moving on then to question number 5, which was the final question in the energy changes past paper. Hot gallons are designed to heat the food inside them, so when it is to be eaten, the heat is generated by mixing calcium oxide and water. Okay, and there's a little diagram of how this works. Okay, during a trial reaction, the temperature reached 50 degrees, but a temperature change of 70 degrees is required to properly heat the food. Suggest a change that could have been made and explain how this would lead to the can reaching a higher temperature. Now, straight away, I can see in the reaction, you add the water on the top, well, that's how the can is set up, and the calcium oxide is down the bottom. So they're not actually, some of the calcium oxide at the bottom is going to remain unreactive because it's nowhere near the water. So mix the calcium oxide and water before placing in the can. The surface area isn't large enough for the reaction, so there's not enough space for them to react. And when they are reacting, some of the calcium oxide, because it's right at the bottom, isn't getting involved in the reaction. The final bit then, when chemical reactions take place, bonds are broken and new bonds are formed. Explain in terms of bond breaking and making why some reactions are exothermic. This is when the overall temperature change is negative. Temperature will increase, but the overall energy change is negative. More bond energy is released when breaking bonds than is needed to form the new ones, so it's released into the environment.